Hi, boys and girls. It's Miss Bissell. We are in our book on page 50. We are starting topic 2 today. Topic 1 naturally flows right into topic 2 because in topic 1, we were learning about decimal and the place value. We were working with comparing, ordering numbers, rounding numbers, and now we're going to work with adding and subtracting decimals using different strategies. So the first lesson we're going to go is to lesson 2.2, and I'm going to ask you to go to page 50 in your book. Honestly, you just need a pencil and your book today, and we're going to start with our essential question. And the question is, how can you estimate sums? The key word here is estimate. And I want you to think back, when we estimate, we're not looking for an exact answer. And sums are obviously answers to addition problems, but you're going to find out we're actually going to be finding some answers to some subtraction problems, which are called differences. So it really should be, how can we estimate sums and differences? All right. So we're not looking for an exact answer. We're looking for an about answer. And this helps us when we don't have access to a calculator. Being able to estimate correctly helps us see if our answer is in the ballpark. Is it close to, is it reasonable? Okay. Calculators and some of the other strategies that we use help us check for precision, but estimating just helps us check to see if our answer is reasonable. So we're going to start. I like the solve and share on page 49, so we're going to use this. We're also going to talk about rounding numbers. So I'm going to remind you of the little saying that I've presented in each classroom. This is the one that you tell me you used in 4th grade. So remember that 5 or more, you're going to raise the score. So what that means is when we underline our rounding digit, if the number to the right of it is a 5, 6, 7, 8, or 9, raising the score means that we're going to add 1 to the rounding digit. If the digit to the right of the rounding digit is 4 or less, then we're going to leave the rounding digit where it is. We don't change anything. So we've worked with rounding a couple times in chapter 1, in topic 1. So this is coming back today to be used with estimating sums and differences. All right, so we have an amusement park. It has 2 roller coasters. One is 628 feet long, and the other is 485 feet long. If you ride both roller coasters, about how many feet will you travel in all? And it tells us to use estimation to solve, but let's break down the problem. So we are going to be wanting to figure out, if we ride both roller coasters, about how many feet will you travel in all? So there's some clues here. When you're asked to find an about answer, you're looking for an estimate. All right. We're looking for both roller coasters. How many feet will you travel in all? That means I'm going to combine the feet from one roller coaster with the actual length of feet of the second roller coaster. So we're adding. All right. So our 5th grade helper tells us that you can use reasoning to decide what you are asked to find. Is the problem looking for an exact answer? And the answer is no, it's not looking for an exact answer. And we know that because of the clue here, the keyword about how many feet. Okay, so when you see that, you know you're not looking for a precise answer. All right, so let's talk about it. If we were to work the problem, we would be adding 628 and 485. That would be the length in feet of each roller coaster. All right, but we're not asked to find the exact answer. We're asked to find an estimate. What I like to do is use front end rounding, and that is where you underline the highest place value digit in your add-ins. All right, in this case, 6 and 4. All right, out to the side is where we're going to put our estimate. So if you want to make a note, our estimate is going out to the side. And what I see is that there is a 2 to the right of the 6. So go back to your rounding rule. If the digit to the right of your rounding digit is a 4 or less, you let it rest. So that 6 will stay 600. Looking at place value, that is 600. All right, the 4 that we're looking at in the hundreds place has an 8 to the right of it. So using the rounding rule, what I know is that that 8 is going to raise the score. So 400 will become 500. And I'm rounding to the greatest place value, so I'm rounding to the nearest hundredth. When I add these together, I get a 1,100 feet. So my answer is the total length of both roller coasters is about 1,100 feet. You will see me sometimes, instead of putting the word about, you'll see me put two little squiggly lines that look like equal signs that are squiggly. You might see me write it about 1,100 feet like this. Okay, that's perfectly fine, or you could write it with the word about. All right, so now let's look at the look back, okay? About how much longer is one roller coaster than the other? Show your work. So my largest roller coaster, as far as the greater value in length, is the 628 feet roller coaster. And if we want to know how much longer, the keyword about tells me I'm going to do an estimate. So I'm going to set it up as a subtraction problem, and then I'm going to do my estimating. That's a subtraction clue. So I'm going to subtract 485 feet to find out how much longer one roller coaster is than the other. I'm going to drop down. My rounding digit is a 6. To the right of it is my 2. That 2 is 4 or less, so I'm going to let that digit rest. So it's going to stay 600. All right, I'm going to subtract 485. Again, I'm rounding to the nearest hundred. 400, I have an 8 to the right. We talked about it a minute ago. 8 is 5 or more, so I'm going to raise the score to 500. So the difference in the two is about 100 feet longer. Okay? All right. So let's flip over to the next page. Now, we are going to not use one of these methods. So I would like you to go ahead and mark out compatible numbers method. State of North Carolina has us using, for the most part, front digit rounding. All right, so we don't need to learn this method this year. So students are collecting dog food to give to an animal shelter. Estimate how many pounds were collected in weeks 3 and 4. There is more one way to find an estimate, but we're not going to worry about compatible numbers. We're going to just practice and master and be able to round numbers using front end rounding to get our estimate. So I'm looking at weeks 3 and 4. Let's go and circle those amounts, those pounds of dog food. So they are going right here to write each week. Week 3, 237 and 5/10. Week 4, 341 and 5/10. When we estimate, we're using front digits, so they should have underlined the 2. That's your rounding place. The 3 behind it is 4 or less, so we're going to let that 200 rest. So 237 and 5/10 rounds to 200, the nearest hundred. The same thing, 3 is the front digit. It's in the hundreds place. We have a 4 behind it, 4 or less. We let that rest at 300. When we add our numbers together, we get about 500. So the students collected about 500 pounds of dog food in weeks 3 and 4. All right. Now, let's go over to a subtraction example. Very similar to what we did on page 49. We're not going to use the compatible numbers. We're just going to round to the front digit. So if we were subtracting 13 and 97 hundredths from 22 and 84 hundredths, our front digits are in the tens place. So next to the 2 tens, we have a 2. That digit to the right of our rounding place, 2 is 4 or less, so we're going to let 20 rest. Oh, wait a minute. I take it back. Sorry, take it back. They rounded it to the nearest whole number. I missed that. I'm sorry. All right. That will give you a closer estimate. We'll talk about that a little bit later. So 22 is the rounding number. They rounded it to the nearest whole number. So the 8/10 is what tells us what happens to 22. Do we leave it 22 or do we round up to the next whole number, which would be 23? 8 would qualify as being more than 5. So remember the saying, 5 or more, raise the score. So 22 rounds to 23. 13 and 97/100ths, we wanting to know, are we going to leave this the whole number 13? Are we going to round up to the next whole number 14? The 9 in the 10th place tells me to raise the score. So 13 becomes 14. When you take 13 or 14 away from 23, you get a difference of 9. All right. So we are going to actually do a couple of these. So I am going to start with numbers 3 through 10, where we're going to estimate the sums or differences. And we're going to start with number 3. 49, that's a whole number. We're going to round it to the front digit 4, so underline that. All right. The 9 to the right of it tells me to raise the score. So 4 would become 5, and we now have 50. We're going to add to it 22 and 88/100ths. Now we could do this two ways. We could round to the nearest 10, which would be the front digit, or if we wanted to get an even closer estimate to the actual sum, if we round to the nearest whole number, then we could round, either keep it 22 or round to 23. I'm going to round to the nearest whole number. So 8/10 tells me that I am going to raise the score. So 22, that whole number becomes 23. For me, that's going to give a closer estimate. If we rounded this up to, or kept it at 20, it might be a little low. All right, so 50 plus that 23 is 73. All right, number 4. We're going to take 18 away from 86 and 9/10. So when we estimate, I am going to round to the nearest front digit, or I'm going to use front digit rounding. I'm sorry. So 86 and 9/10 rounds, that 6 in the ones place tells me to round up to 90. And I'm going to subtract. 18 is going to round to 20 because the 8 to the right of my front digit tells me to raise the score. So that's going to become 20. Those are easy numbers for me to mentally add or to subtract. And to be honest, I want to do what is easiest when I'm working with estimating, because I want it to be mental math. Because most of the time when adults estimate, we don't write our estimates down and do the math on paper. We do it in our heads. So most adults would look at this and round it to 90, round this to 20. Since we know 9 minus 2 is 7, we know 90 minus 20 is 70. And we'd get a quick estimate of that difference. All right, let's look at number 5. Number 5, 179. And we're adding it to 277 and 1/10. Again, to make this easy, quick mental math, I'm going to use that front digit rounding. And so I'm going to underline the 1 in the hundreds place in both of my numbers. The tens place is going to tell me what I'm going to do to the hundreds place. So the 7 tells me to raise the score because it's 5 or more. So this number, the first add-in, becomes 200. Looking at 277 and 1/10, the 7 in the tens place is greater than a 5, so it tells me to raise the score on my rounding digit, so this becomes 300. All right, real quick, you can do that in your head. 200 plus 300 is 500, and that's because 2 plus 3 is 5, and then you're working with hundreds. Okay? The next number, 23 and 2/10. We're rounding to the nearest front, or to the front digit. So I noticed that 2 is my front digit and 9. So in 23 and 2/10, the 3 in the ones place is less than 4. So let it rest. So this stays 20. And 9 and 71/100ths, the whole number 9 becomes 10 because the 7 in the tenths place tells me to raise the score. The next counting number after 9 is 10. You know what? 20 minus 10 is 10. All right, number 7, rounding to the front digit. I want you to notice every time I'm underlining it. Oh, sorry, I jumped to problems. Every time I'm underlining it, and I'm looking at the digit at the right, to the right of the rounding digit. So the rounding digit is underlined, and the digit to the right is the one that I'm using to make the determination whether I'm going to round up one number or do I leave it where it is. Page 63 in your math journal. We've referred to that before on 2 lessons. This right here will help us if you want to refer to this page. It has your steps right here. All right. The 3 in the ones place tells me that I am going to let the 2 rest. So this rounds to 20. 4 and 7/10, the 7 in the tenths place tells me that I'm going to raise the score to 5. 20 minus 5 is 15. All right, we're going to keep on moving. Number 8, the 87 and 2/10, we're going to round to the nearest 10. The 7 in the ones place tells me to raise the score. This would round to 90. 3 and 9/10, 3 is where we're going to round to, the nearest whole number. The 9/10 tells me to raise the score to the whole number 4. 90 plus 4 is 94. All right, ladies and gentlemen, 38 and 9/10, we're going to round to the nearest 10. The 8 ones tells me to raise the score and round it to 40. The 21 and 4/10, the 2 is what we're going to round. The 1 tells me to leave it alone, so it's going to stay 20. Let it rest. 40 minus 20 is 20. 576, we're going to round to the nearest 100. The 7 in the tens place is greater than 5. 5 or more, raise the score. This would become 600. And 94 and 6/10, we're going to round the 9, the front digit. The 4 in the ones place tells me to let the 9 in the tens place rest, so this would round to 90. 600 plus 90 is 690. Now, we've done quite a few problems. We are using front digit rounding. As a matter of fact, I probably should not at number 3 have rounded that to 23. Let me go back. We're going to just leave it at 20. I kind of got off track and started working with some other strategies. 50 plus 20 is 70. So I'm going to go back and correct myself there. All right, front digit rounding. So what I want you to do is pause the video. Let's see how you do with 11 through 18. Again, I want you rounding to the front digit. So let's make a note here to use front digit rounding. Okay. Pause the video, work out these problems. They should be really quick, and then come back and let's look at it. If you need to, use page 63 in your journal. Here are your steps. Here's your rounding rule, okay? All right, let's check your answers. All right, this is my work. So when you add 79 and 1/10 to 32 and 4/10, you are rounding to the nearest tens. 80 plus 30 gives you 110. When you round 788 and 9/10 minus 572, you're rounding to the nearest 100. So you should have 800 minus 600 equals 200. Number 13, you're rounding the sum of 837 and 488 and 12/100ths. So you're rounding to the nearest 100. 800 plus 500, 1,300. When you round, you don't even have to worry about these decimals. You're rounding to your whole number places on these, aren't you? Number 14, 418 and 5/10, subtracting 23 and 7/10. You're rounding this one to the nearest hundred and this number to the nearest 10. 400 minus 20 should be the numbers you use to get an estimate of 380. Number 15, this one you are rounding to decimals. You're rounding to the nearest whole number. So 2 and 9/10 rounds to 3, 3 and 9/10 rounds to 4, 3 and 4 gives us a sum of 7. Quick estimate. Number 16, you're rounding to the nearest, I did that one wrong because we're going to be rounding to the front digit. So $12.99 rounded to the nearest $10. That's going to be $10. $3.95, we're rounding to the nearest $1. That 9 tells me to raise the score, so I'm going to be subtracting $4. So $10 minus $4 is a difference of $6. And again, this is just an estimate, so it's not exact. It's just going to help us when we actually do our sums and differences. 8 and 1/10, rounding to the nearest whole number, rounds to 8. 3 and 7/10 rounds to 4. 7, 9 and 9/10 rounds up to 8. When we add these three add-ins, we get 20. 3 and 8/10 rounded to the whole number is 4. 4 and 1/10 rounded to the whole number is 4. 3 and 3/10 rounded to the nearest whole number is 3. When we add those three add-ins, we get 11. So I hope everybody did a good job with those 8 problems. All right, now let's look at some of these problems in word form on the back of the page 52, and then we'll be wrapping it up. So on page 52, number 19 tells us that the cost of one DVD is $16.98, and the cost of another DVD is $9.29. Ed estimated the cost of the 2 DVDs to be about $27. Is his estimate higher or lower than the actual cost? All right, so let's talk about this. When I go to round these numbers, all right, Ed's coming up with $27. So I'm thinking what Ed is thinking about is $16 plus $9. Nope, that wouldn't be right. Nope, he must be doing $17. Okay, I take it back. He's doing $17 plus $10. So he's rounding up to the nearest $1, $16.98. So Ed is adding $17. And he's actually rounding $9.29 incorrectly. He's rounding it up to 9 or leaving it. No, he's right. He's actually rounding it up to 10 when he should be leaving it at 9. That's what I'm trying to say. So Ed is estimating it to be $27. Now, what I notice is that his estimate is higher than the actual amount. And that is because Ed used numbers that are greater than the actual add-ins. So look at this a minute. I had to figure out what he was doing first. So now that I figured out how he came up with $27, he rounded $16.98. He used $17. Then when he added $9.29, he actually rounded it up to $10. So that's how he gets $27. Okay? That's where it comes from. So since his estimated add-ins are larger than the actual add-ins, his estimate's going to be a little bit higher than what the actual sum is going to be. So now that we figured that out, we can just write a quick little sentence and we can say that it's going to be higher. His estimate is going to be higher. And that is because Ed used numbers that are greater than the actual add-ins. Get my hand out of the way here. So his estimate is going to be a little bit higher than what the actual answer is going to be. All right, I love this next question. A teacher is organizing a field trip. A bus can seat up to 46 people. Is it better to estimate a greater or lesser number than the actual number of people going on the field trip? Why? So if I'm estimating, do I want to estimate a greater or lesser number of the actual number of people going on the trip? All right. I hope you guys are thinking, Miss Bissell, you need to estimate a greater number. Because if I underestimate, I am not going to have enough room for everybody. So if I estimate with a greater number, then what's going to happen is I'm going to make sure I have enough seats for everybody, because I know nobody wants to be left behind on a field trip. So we're going to use a greater estimate, and that is because we want to make sure there are enough seats for everybody. Nobody wants to be left behind. Okay? All right. And number 21. We're going to wrap it up right here. This is the last word problem we're going to use that has some estimating in it. So the size and the shape of the Golden Gate Park are often compared to the size and shape of Central Park. About how many more acres does Golden Gate Park cover than Central Park? So here's an aerial view of the two parks. Both of them are basically rectangular shape. So Central Park in New York City has an area of 843 acres. Golden Gate Park in San Francisco, California has an area of 1,017 acres. So the question was about how many more? So I see two key things there. First of all, I do not need an exact answer. I need an estimate. The second thing is I know I'm subtracting because of the word clues, how many more. So the larger of the two parks is 1,017. That's our park in California. So if we subtract the 843, the acreage of the park in New York City, we can find the difference in size of the two parks. Now we're going to estimate. So we're going to round to the nearest 1,000, the front digit in this number, and the nearest 100, the front digit in this number. So I'm just going to drop down and take care of it right here. The zero in the hundreds place tells me that I'm going to let it rest. So I have 1,000 as an estimate for my New York City park called Central Park. And then the 4 tens tells me I'm going to leave the 800. I'm going to let it rest, and I'm going to subtract the 800 estimated acres that I have. Oh, whoa. Go back. Sorry. 1,017 estimates or rounds to 1,000. That's the Golden Gate Park. The 843 is the New York City Park. Now, the difference between 1,000 and 800 is 200. So the difference in acreage between the two parks is about 800 from 100, about 200 acres. Okay? So we have been adding and subtracting using estimation. We've been rounding our digits to the front digit, rounding our numbers to the front digit, and adding and subtracting to get an estimate. And the estimate is going to help us when we move on in our next lessons to adding and subtracting decimals. All right, boys and girls, you have a practice buddy assignment that correlates with lesson 2.2. You will probably want to have your book out so you have some examples, and I will have you work on your practice buddy. Don't forget, you have 1 dream box and 2 of your weekly review problems that you need to make sure you're getting done as well. All right, have a great evening.